Now that we've learned a lot about whole number numeration systems and whole number operations, we want to spend some time looking at whole number puzzles as well. You'll see that I have a resource here. I say resource because if you're going to be an educator in the future, and I think many people taking this class are, openmiddle.com has a lot of whole number type puzzles which allow the students to start at the same place, then trouble themselves with a lot of puzzling and figuring out, many times using the ideas of place value to come to an answer or multiple answers at the end. Let me go to that website and just briefly share that with you before we get in and tackle some problems ourselves. So this is the openmiddle.com website. You can see across the top, you can access many different grade levels. For example, if you're teaching third grade and you wanted to talk about number and operations in base 10, which is something like what we're doing in this class, then there's a bunch of problems that you can choose from here. If you choose on a problem, like let's say subtraction with zeros is a task that we're interested in, it's going to pose a problem, it's going to have a hint and an answer as well, and you can use this as a teacher tool. This one actually says directions, using the numbers 1 through 9 at most once to make this a true subtraction equation. What is the greatest difference? What is the least difference? This is actually similar to a puzzle I'm going to ask you about on homework as well. And so let's take a look at some of the tasks that I've already pulled out and give you a chance to think about it here with me. So I have 3 different tasks from Open Middle. This first one, the claim is, I have a K there because the claim is it's a kindergarten task. Let me be transparent and just tell you that sometimes the kindergarten and first grades tasks really challenge me as well. So the directions here say using the digits 1 to 5. So we're thinking about the use of 1, 2, 3, 4, and 5. At most one time each, you can't repeat. Fill in the boxes to create 2 or more true number sentences. Well, the first one that stands out to me, of course, is 1 plus 2 equals 3. That's fairly obvious. You could do 2 plus 3 equals 5, or you can do 3 plus 2 equals 5. You can also see 1 and 4 is 5. You could see 3 and 1 is 4. There's a bunch of different number sentences that are possible, but this would be a great challenge for a kindergartner because there's so many answers that can work. It's kind of fun to scramble for them. Let's take a look at a 4th grade challenge. Now, 4th grade challenge might be quite a bit trickier. And this one says using the digits 0 to 9 at most one time each, fill in the boxes to make a true statement with the greatest possible total. Wow, we got several challenges there, right? We have to use the digits 0 to 9 at most one time each. Can't repeat, right? We have to make a true statement because this is an equation, right? And then lastly, we're also trying to go for some greatest possible total challenge. So there's really 3 things going on. It might be even tricky to find even one. Well, if I want the greatest possible total, I can see something times something plus something times something. If I want to make it large, maybe I just choose the very largest I can do, which is 9 times 8. 9 times 8 is 72. Make a little note of that here, it's 72. I want to add in something else, becoming something else. So if I did something large here as well, like let's see, okay, 7 times 6, that's 42. That's also pretty large. But if I add those together, I actually get a 2-digit number, 114, and it doesn't fit in there, does it? So I can't do something quite that large. So maybe I try something smaller so it doesn't exceed 100. Well, the problem is, if I choose something smaller that's in the 90s, I can't do that either because I'm not allowed to put a 9 here because I have already used a 9. Likewise, I'm not really allowed to put an 8 here because I've already used an 8. And so it might turn out that maybe 9 times 8 isn't the best thing. I really don't know. My guess is it's probably not the best, but I haven't really done this problem and I don't know the answer. That's what makes it exciting. So you would try to work through this task until you can come up with something different. Like maybe if I put 1 times 3, which is 3, I come up with 75 and at least have a true statement. Notice that that doesn't break any of the rules. I've used the numbers 0 through 9, the digits 0 through 9 without repeat, and I did make a true statement. Is it the greatest possible total? I doubt it. And so what's fun about these tasks is you can keep working on them even after you have a solution and keep working on them until you figure out something even better. But we're going to stop it at that. Here's a 3rd grade task where you would be adding the digits, adding 2 3-digit numbers using the digits 1 to 9 without repeat, trying to make something larger than 700 and something smaller than 700. And that could be fun for a 3rd grader. So those are all tasks that are pretty cool from that site called OpenMiddle or openmiddle.com. I want to also take a look at alphabet math problems, which are a different whole number type riddle. And we're going to do a few of these for homework as well. So let's take a look at the directions. Each letter in these stands for a digit 0 to 9. All right. So if you see bark plus bark equals tree, each one of those letters is an individual digit. Okay. In a given problem, the same letter always represents the same digit. So an example there is on bark plus tree. There's 3 R's there, and all of those R's would represent the same digit. Okay. That's number 2 here. Number 3, there's no relationship between the problems. Okay, so here I have 2 different problems. I also have Coca plus cola is soda. I'm not going to do both, but I'm just giving you an illustration. So if you were to solve the task on the left first and figure out the value of A, when you went to the second problem to figure out the value of A could be totally different, right? It's an independent problem. And then it also says 2, 3, and 4 digit numbers never start with a 0. So the leading digit, I'm highlighting all of the leading digits, would not be zeros. We don't start with a 0. And the last line says our job. Our job is to figure out what each digit stands for, what the letter stands for, until the calculation is correct. So we'll just look at one of these together. It'll be enough of a challenge. Bark plus bark equals tree. Wow. So you'll notice a lot of repeats here. I have K plus K, R plus R, A plus A, B plus B. So it might be useful if I actually knew all my doubles, or at least had a list of them written down. So let me write some down. So I know 0 plus 0 equals 1, and then 1 plus 1 equals 2, 2 plus 2 equals 4. And I'm just going to write down the answers, okay? Let's use a smaller pen. 6, 8, 10, 12, 14, 16, 18, right? Those are all the answers. So it'd be 3, to fill in the details, 3 plus 3, this is 4 plus 4, this is 5 plus 5, this is 6 plus 6, this is 7 plus 7, this is 8 plus 8, and lastly 9 plus 9. Now, the reason I wrote down all the answers first is I'm just realizing I made a mistake. You probably already noticed it in the video. I'm noticing it now. 0 plus 0 is not 1. It's actually not 1. It's actually 0, right? Okay, gotta have that correction. So what I wanted you to notice as I wrote down all the solutions is that they're all even numbers. When you double a digit, you always end up with an even because it's basically times 2. Notice they all have the digits 0, 2, 4, 6, or 8 in the ones place. That's going to be significant if we're going to solve this riddle. Okay, the other things that we can notice are what we know about place value. If you look at the thousands place, we have B plus B is T. Notice how we didn't have a digit go to the 10,000s place? That tells us something about B. B has to be smaller than 5. And I'm going to draw a line there so you can see. Because if B was, for example, 5, 5 plus 5 would give us 10. We would have a 1 carried over to the next place. Also, B could not be a 0 because you can't lead with a 0. And so that means really that B has to fall somewhere in the range between 1 and 4. So that's something you can note. You can put a little note. You can put notes anywhere you want. You can say something like, okay, well, B can either be 1, 2, 3, or 4. That's nice to notice. And then you might try something like that with some of the other things as well. So let's see what else we can notice by looking at this. Well, I also notice that we have this E thing going on here, and that's kind of interesting to think about. K plus K is E, but it looks like R plus R is E. Now, how can that be if they're different digits? Well, what can happen is if you look at this list of doubles, and I'm going to take away these lines so you can take a better look at it, you'll notice that although they don't repeat the answers, they do repeat the ones place. So if you look at, let's say 3 plus 3 is 6, and you look further down the list, you'll notice that 8 plus 8 is also 16. So they both have a 6 there. So we could do these two, 3 plus 3 would be 6, and then we could do these two, 8 plus 8 would be 16, where this would be a 6 carrying a 1. So those are things to think about. Now, well, but where do we get started? Do we just want to go randomly? No, we don't want to go randomly. So we have to really think purposefully about how we're going to do this. So, well, let's see. Going back to what we said about noticing these numbers here, they're all even. That lets me know that E itself must be an even digit. Okay, that's significant. So I can make a note of that. I can say E should either be 0 or 2 or 4 or 6 or 8. And if I don't know which one, I could just guess and check. It might be there's multiple answers. It might be there's only one answer. Now, I've already worked this problem, so I'm going to purposely pick something that's wrong. Let's imagine that I think E is 8. Let's see what would happen. If E is 8, then I could say, well, this addition problem becomes that I have an 8 here and I have an 8 here at the very end. All right. Now, how can I get an 8? Well, either 4 plus 4 is 8 or 9 plus 9 is 18. Now, I have to start with 4 plus 4. Let me tell you why. If you started with 9 plus 9, you would actually carry a 1, and that would cause it to be an odd number. So you must do 4 plus 4 is 8, and that would give you the K's. And then the R's must be 9 plus 9 is 18, carrying the 1. I've kind of worked this part of the puzzle already. Now, once you get R, notice there's an R here as well, so that R must match. So if this is 9, then down here must also be a 9 as well. How can I get a 9 there? Well, remember, I've carried a 1, right? So this 1 is going to add with 2 other digits to make 9. So the most obvious thing is 4 plus 4. 1 plus 4 plus 4 is 9. That can't work because I've already used the digit 4 for K. I can't use it for A. The only other way to get a 9 besides that is 9 plus 9. 9 and 9 is 18 plus 1 more is 19. But I can't do that because I've already used 9 for R. And so that means I'm kind of at a dead end. Or in other words, my initial guess that E was 8 fail. So then I can go back and update my list. Okay, now since I've already worked this problem, similarly 6 won't work. So I'm going to jump over and say, what if E was 4? Let's try to put 4s in here for E. If you use the same strategy, 2 plus 2 is 4. And the other way to get a 4 at the end is 7 plus 7 is 14. 7 and 7 would carry a 1. And then remember, these R's link here, right? So this 7 will link down here and cause a 7 to be there. How could I have a 7 there? Well, I can do, the obvious one would be 3 and 3. And if I try that, 1 and 3 and 3 is 7. And that works out pretty well. But then that takes me to the last place. I need to figure out B plus B equals 2T. Now, the issue is, remember, B can only be either 1, 2, 3, or 4. But I've already used 2, 3, and 4. All that's left is 1. But 1 plus 1 is 2. And I can't do that because I've already used a 2. So it's like, wow, I'm really out of luck. Well, if I think back to where I actually had a choice, where I had a choice, but I didn't tell you about it, was right here when I put 3s. It doesn't have to be 3s. There's another way to get a 7. Okay, let's think about it. If there's a 1, I could get 17. And I could get a 17 if this was an 8 and this was an 8, because 8 plus 8 is 16 and 1 more is 17. And that would cause me to carry a 1 here. Then I would be allowed to use 1s, so that 1 and 1 and 1 is 3. And that actually would work. You'll see if you look at this puzzle carefully, and you can pause it, I did use the digits correctly. So 1872 or 1872 plus itself is equal to 3744. There might be other solutions, but that's how an alphabet puzzle works.